and the little red light is now blinking. So welcome to the second Friday here in March. Why are electric vehicles the way of the future and what you should do about it? I'm very pleased to have two of our very own climate change working group members and longtime members of Office for Sustainability and pretty much every effort here in this town to electrify everything. Dr. Paul Pancella is a chair and professor of physics and I think is also heavily involved in the Kalamazoo Electric Vehicle Association. So definitely we want to plug that organization and get involved with them. Dr. Steve Burtman is an organic and atmospheric chemist who's appointed in the Institute of Environment and Sustainability. Many of you know his work from Hope for Creation, but today I think he gets to talk about the things that the science part that he actually knows a lot better. So I'm going to turn it over, Steve, Paul, electric vehicles, the way of the future and what you should know about it. Thank you so much for coming and sharing your expertise with us.
Well, yeah, thanks, Denise, and thanks to everyone for showing up for this. I'm going to be the MC today for a topic that is getting an awful lot of press for good reason, and some of which we will talk about. I am, though, just in full disclosure, I'm at best an interloper, at worst just a neophyte of electric vehicles. The real expert in the room is Paul Pancella, who built his own electric vehicle back before any of us knew that they existed. And so I'm going to be monitoring the chat room and trying to answer as many questions as I can on the fly, and then try to organize the others for answering at the end of the presentation that Paul's going to give now. So if you have a question, go ahead, put it in the chat now, and we'll try to get to all of them. And without further ado, if you want to share your screen and take it away.
Thank you, Steve. Thanks to everybody for coming. I usually defer to Steve Bertman for his superior knowledge on environmental matters and science in general, but in this case, I guess I do have a little more experience in this particular area as noted, and I certainly do enjoy talking about it. So I appreciate the opportunity given by the organizers for today to share some stuff. It's a talk that we both developed. Steve was generous in his advice and counsel, but he also let me have the final say in what was included. So I take responsibility for any errors or incautious statements that will be made. So as Steve said, yeah, we do have a lot going on, and so it's a fortuitous time to be talking about this. We've tried to tailor this for this audience, so I hope that we will find this relevant. But I think that we're here because lots going on. No fewer than 17 countries have recently announced plans to actually ban the sale of internal combustion cars at various dates in the future. France has even put that into law at this point. The new presidential administration here in the United States certainly seems to contrast with the previous one in issues relevant to electric vehicles, including national emission standards and clean air policies. He even says that the entire federal fleet of light motor vehicles will be converted to electric power again at some point in the future. So in the similar vein, we may see a return for some more tax credits that have expired for certain manufacturers. General Motors made a big splash not so long ago, announcing their intention to stop selling gasoline-fueled light vehicles by 2035. Almost unbelievable. There's evidence that although electric vehicles have been up and down over the years, in fact, electric vehicles are nothing new. They were rather common 100 years ago, but now it looks like there are lots of good indications that they're here to stay and will form a major part of the transportation mix in the coming days. So here's a prediction from one reputable financial advising company on sales in the United States. No, this is global, sorry. Global passenger vehicle sales projected into the future. ICE is our abbreviation for internal combustion engines. PHEV stands for plug-in hybrids. I won't go into details about that unless people ask. I'm mainly interested in talking about the last category, BEV, which stands for battery electric vehicles, which take all of their energy from electricity and store the energy on board in storage batteries. Okay, so to get to my main summary of what I'm going to say, the spoiler alert, we want to give some evidence for our view that there really are environmental benefits, particularly for this group in the area of greenhouse gas emissions, for converting away from internal combustion toward electric vehicles, and that there aren't any really big downsides from the environmental side if we really do that at a fairly large scale. And that I won't, of course, say that that's a magic bullet that's going to solve all of our problems if we do this, but that if you look at all the things that we need to do, this one almost qualifies as a no-brainer. It shouldn't be that difficult to accomplish because of a lot of things are just good for even for the drivers. There are a lot of attractive components beyond the environmental pluses for driving electric vehicles more. So that'll be the two things that I'm going to talk about, but we'll start with the one probably most of you are interested in, and that's the environmental side. Okay, obviously, so I'm going to go kind of quick because as usual, I have a lot to say. So I apologize for that if it's too quick, but this audience probably understands that battery electric vehicles don't pollute right in their vicinity because they're not burning any fossil fuel on board. But of course, we realize that energy has to come from somewhere. So you get the long tailpipe argument. The electrical energy in general comes from power plants of some sort. A lot of it comes from fossil fuel power plants. So aren't we just displacing that pollution or whatever the environmental effects to a different location? I'll address that. For the traditional air pollutants, the nitrous oxides, the carbon monoxide, the unburned hydrocarbons, those, of course, we don't have from the electric vehicle. And that classification of pollution that goes into the air, fossil fuel power plants are generally better at controlling those than millions of cars are, just because it's harder to deal with millions of sources, basically. And even a car that is sold off the lot with very excellent pollution control 10 years later might not be that great. Whereas you can keep an eye on your pollution control, your scrubbers in the power plant, and the EPA is looking over your shoulder. So I won't spend any time on the usual air pollution, smog issues, and things like that. We'll go right to greenhouse gas emissions. And then the other thing that differentiates electric vehicles, you need a big battery pack. And what impact might that have compared with the standard combustion engine car. So greenhouse gases first. This is a big deal. I don't have to tell you, again, I can save time. Don't have to tell you that carbon dioxide is an important thing to worry about. It so happens that in our culture especially, which is based on freedom and mobility, that a lot of the carbon dioxide that you and I are responsible for comes because we like to drive around. We have to drive around, or we like to drive around, or both. And we do it mostly in cars. There are areas where mass transit is effective, but there are a lot of parts of the country where it's not so effective. I'm not arguing against any of those things. I'm a cyclist myself, although as I get older, that gets more difficult. We should be designing our cities to have less cars overall, more friendly to other kinds of travel. But it's still the case that people want to have the freedom of their cars. Some need to be able to go where mass transit doesn't go, are not able to walk or bike. We have winter. And so another way to reduce the huge impact of cars on emitting greenhouse gases is to replace them with electric vehicles. And electric vehicles now are able to do just about everything the cars can do, so that you're not asking people to sacrifice very much. It's not, and that'll be the second part of my talk, so that it's a good way to think about going. But the first point to make is that there is an actual potential significant reduction in greenhouse gas emission by doing this, by replacing the internal combustion cars with battery electric vehicles. Now, there's a lot of possibility for confusion here, and that's partly what I want to try to help deal with. There's the opportunity for some parties to use that confusion to their advantage. And so there's a lot of information out there, especially on the internet, that can be very confusing. But I'll try to put over what I believe is pretty much the correct situation without going into all of the details. So here is one of our usual famous pie charts that shows the distribution fairly recently of greenhouse gas emissions by source in the United States, broadly defined, where transportation appears here and accounts for about 28% of the total greenhouse gases emitted in a year, and it's fairly stable from year to year. Hasn't changed that much since 2018. So pretty good indication. These things change a little bit. What I'm gonna say is, I don't know if you can see my cursor. Can you see my cursor? So what I'm talking about is moving this line over and decreasing this red chunk. But of course that means increasing this blue chunk, because you have to make the electricity that powers the cars if you're going to do that. But what I will show, or at least I'll tell you, is that if this were, instead of relative proportions, if this pie was the actual absolute amounts, the amount that I would take away from the red will be less than the amount that I have to add to the blue. And so in that sense, the entire pie would get smaller in proportion to how many of those cars I convert. It's pretty much that simple. The exact proportion is the hard part. Okay, so if I want to get the exact proportion, I'm going to break that red chunk into what the actual transportation modes are. And again, this is fairly stable. And this makes my point that I said before, that there's a lot of other transportation going on, but our little passenger cars big chunk of it. And not only that, but a lot of people are using pickup trucks and other small trucks basically as passenger cars. And all of these pretty much are pretty easy candidates for conversion, changing over to electric. It's not, with present technology, it's not a very difficult task to do that. And so I'm going to concentrate on that 62% of that pie that I had before and say, just to get a number, what if I could do all of that? Okay, if I could do all of that 62% of the greenhouse gas emissions in the United States, I'd be getting rid of 1,167 million metric tons of emitted CO2, just like that. And the amount that I would have to add to that electricity slice, based on how we currently generate our electricity across the entire United States, would be only about 360 million metric tons. Why is that so different? There's a lot of reasons for it. One is that the electric vehicle, on its basic principle, is a more efficient way to use energy. Once you get the energy to the electric vehicle, it's going to use it much more efficiently than an internal combustion car does. This is actually what originally attracted me to this whole topic many years ago, because from the physics point of view, you very early on appreciate the importance of energy, and then you get into a chapter where you see what happens to the energy in a car, and you go, oh my God, it's crazy. But the second point is that not all of the primary energy we use to generate electricity produces carbon dioxide or even any greenhouse gas emissions, whereas all of the gasoline that you burn does produce carbon dioxide. So on units of energy produced, the electricity is already better and getting better. And we'll talk more about that. You might say, well, I'm going to have to add a lot more generating capacity. Well, you probably have to add some generating capacity. And it's not immediately clear, since we can't do this at the snap of a finger, it's not immediately clear that you would just add in the same mix. You might have to add more natural gas or go back to coal or something. That we have to talk about that. But in fact, because of the flexibility of when you charge your electric vehicle, there's really a lot of off-peak capacity already available in the present mix to provide a good chunk of that electricity. So it's not that bad as far as adding more. So if you could do that immediately, you could that ratio would be in effect, and you would be a result in a significant amount of carbon dioxide reduction emitted in the country every year. Now, of course, you can't do it immediately, but that corresponds to 12%. So even if you do 1/10 of it in 1 year, you're actually making an actual reduction. And it's, I mean, just looking at the history, actual reductions are not that easy to come by. So it's nothing to sneeze at, even if it's gradual. And it will be gradual, of course, because cars on the road right now a lot of them will still be there in 10 years. No matter what we do. Okay, to reinforce, I'm just going to go through some Sankey diagrams quickly to reinforce that point I made, that a lot of energy is not going to the road in the gasoline powered car. The first thing you do is you burn this fuel, and thermodynamics says you're at best going to get 40% of that energy converted into mechanical energy. And then you got a lot of friction and a lot of other systems to drive, and you got more friction, and then you're spending a bunch of time idling at stop signs and stoplights, and then you're finally getting the car moving. And these are actual realistic percentages. I didn't make these up, I verified these. And I'm including now at the end some loss to braking, because if you get the car moving, you got your kinetic energy, And then if you come to a stop in a regular car, you rub that energy out and make more heat and wear down your brake pads. And that's another thing that's different in electric cars. So if you can get the same amount of energy stored into your car in the battery, you're going to waste a lot less of it. That's why you don't have a big radiator in an electric car. The grill in the front could be closed. The conversions are much more efficient. The transmission is unnecessary. And you don't have to idle. It's one of my favorite things. You don't have to keep the engine running at the stop sign. And you can regenerate the kinetic energy when you slow down. Instead of wasting it, you can put most of it back in your battery. So I'm even ignoring the losses to braking friction, which are still small, but to first order, we can ignore them. So you can do the same job basically with 1/5 as much energy stored in the car. Okay, you still need to generate that. And if you generated it all with combustion of some kind, you'd still have that penalty from thermodynamics at the beginning. But if you notice, this arrow is still bigger. It's still about twice as big, even if it's not quite twice as big, but it's still bigger if all of your energy is from combustion. Even if it's coal, it's still better. If it's all from coal, it's still better, but it's only a little bit better. Fortunately, we're not using coal exclusively for generating our electricity, even here in Michigan. So in Michigan, if you took our current mix of generating capacity, which relies on coal and natural gas, as well as some nuclear and some renewables, you could keep track of how much CO2 would be emitted by your regular gasoline car, and that would be the top line. And this is added up over years since purchase. But if you used an electric vehicle locally, it'd be about half. And that's the solid red line. If, as we anticipate, consumers and Detroit energy continue to shift more toward renewable sources that are less carbon intensive, then the slope of the red line is not constant. It gets shallower and shallower as the years go by, and it's even better. So whereas you can't do this with your gasoline powered car, once you buy the gasoline powered car, you're stuck with that fuel for the life of the car. With the electric vehicle, that's essentially not true. Advances in fueling the electric grid translate into better carbon dioxide emissions, lower carbon dioxide emissions for every electric vehicle on the road. Okay, so where are we? So we've talked about air pollution. I didn't talk about other effects of recovering petroleum from underground, refining it, possibly spilling it when you transport it around, energy used in refining. Obviously, we're not talking about getting rid of all petroleum, but the less you use for cars, the less these things would have negative impact, and that the carbon dioxide is significantly reduced. So what do we have to pay for that? What are the trade-offs? Well, we will have to make some more electricity, and we'll have to distribute that somehow. That probably means some more power plants. I think we have to seriously, if we're concerned about CO2, that means we have to be looking at nuclear power seriously. It's gonna, if we penetrate farther and farther into the car market, but if we also do this with other parts of our energy economy, which long-term I think is the best way to go toward carbon neutrality in general, it does mean relying more on electricity. And if we don't cut back our energy use a lot in absolute terms, it probably means we have to upgrade the grid. But we have time to do it. We have to do this gradually. And we have to worry about the intermittency of many of the non-CO2 emitting sources and invest in big technology for storing energy at a large scale, which we haven't quite proven yet. So these are the areas we have to concentrate on, but they're monetary investments, they're policy priorities. They don't seem to be, they probably don't have big negative environmental impacts. So the last part of the environmental part is the batteries, what's associated with manufacturing and disposal of these big batteries. These batteries are something new. A lot of the car is the same, the tires, the suspension, the windows, the seats. What's different are the guts that make it go. We don't have to worry about catalytic converters. You may have seen the price of the metals used in catalytic converters going up. We don't have to worry about that. But we do have to worry about a rather large battery pack. With current technology, that's a big chunk of stuff that displaces the other stuff that you don't have to worry about, the fuel tank and stuff. And it's got a lot of mass, so it's appreciable. What people don't realize probably is that very little of the mass of a lithium ion battery pack is actually lithium. It's only a couple percent. There are other metals involved, mostly copper and aluminum for the conductors, but also various combinations of cobalt, manganese, and nickel. And again, there's a lot of details here I'm glossing over, but presently, there is some concern about the cobalt mining. So I just noted that we're at about 5% by weight of this big battery is actually cobalt. There's a picture here of the battery in my electric car. It takes up almost all the floor, right under the floor and under the back seats. Okay, so here's a busy slide, but on the right are some pictures of current battery cells. They come in different configurations. A battery pack is made up of hundreds of these cells, and that's the unit, that's the sealed unit that you would have to deal with. You have to manufacture on one end and dispose of on the other end. And here is current on the left side. Currently, the proportion of all these different materials that are typically in batteries of this kind. Okay, this battery technology, I mean, it's familiar to me, so I may be taking this for granted, but we're not talking about lead acid batteries anymore for storing the power. Not the kind of battery that you're familiar with that's really heavy that was used to start your car. This is a whole new technology that a Nobel Prize was awarded for because it's so important and disruptive, and it's enabled so many things. It's enabled this laptop that I'm using right now, all your cell phones to have power for days on end. And at a larger scale, it's enabled the electric cars to actually be competitive on the highway. So here's what's in them. Starting at the bottom is that little tiny bit of lithium, that little small bit of cobalt, usually more nickel. Graphite is a big part of it. That's just carbon, solid carbon. Okay, we can capture carbon dioxide and make it into carbon, make for our batteries. Little manganese, copper, a little bit of steel, good amount of aluminum, a little bit of iron. And this other junk at the top is plastic and some binder chemicals and the liquid electrolyte, which they're filled with still that's an organic solvent of some kind. There's work on making these batteries solid state. That would be another technological leap. Hasn't been proven yet, but it might come and in the next 10 years and disrupt this again. But that would eliminate the liquid part of it and have a lot of possible improvements. But I won't have time to get into that. But if if this technology is not disrupted, there's still progress to be made because it's still pretty new. There's still progress to be made in squeezing more energy storage capacity out of less material. Okay, and so this is a projected trend by somebody. I don't think it's unreasonable. Other authors agree that on this time scale of 15 years, we'll be able to reduce the amount of material in all these categories required to do the same job. This is scaled by how much mass is used to store a given amount of energy without getting into the details of the units. So that's good news for any discussion of the impact of manufacturing or disposal of these batteries long into the future. And the future is what matters. Well, I'll get into that later. So again, to set the scale, it's not huge amounts of this material. If in the most optimistic scenario for market penetration of electric vehicles globally, the global lithium mining industry would have to increase its capacity by about a factor of 5. I have the reference there for that. I think it's fairly reliable. I mean, it's projecting into the future. You never know what the future is going to be, but based on some pretty good trends. And in the past decade, lithium production has already grown by a factor of 3.5 because of all the other uses for lithium-ion batteries. At present, there are 2 major areas where lithium is extracted. They are the South America high salt deserts and Australia, where it's more traditional mining. In South America, it's a pretty low-tech process of injecting water into these salt flats and taking dissolved material out, letting it evaporate again, and then processing it. So there are issues with water in those areas, but they're not, in my judgment, they're not super serious. And expanding that's not going to be a huge problem if we're basically responsible with controlling runoff and using the water efficiently. And in other places, it's standard hard rock mining of ores with the usual environmental impacts that we can deal with. It's also possible that I think that it's actually likely, if the price of lithium goes up because of demand, that there'll be more ways to recover lithium from the Earth's crust. And some of those ways are potentially even less harmful to the environment. I think in the cobalt case, a lot of the objection has been not exactly widespread environmental damage, but human rights issues. And that's because of a quirk of the geography. The cheap way to get cheap places to recover cobalt right now happen to be almost all located in one country in Africa, the Democratic Republic of Congo. And so it's ripe for exploitation of local labor, and responsible companies have to deal with that. There's no question about it. I don't want to minimize those concerns, but they're not necessarily, it's not required that we have environmental damage beyond what would be typical from mining operations. And it's not as much as mining coal. Just the magnitude is just orders of magnitude smaller. So the other concern is exposure to radiation because of the uranium nearby. But again, with reasonable care, not huge things. Add to that the fact that these batteries last a pretty long time. They gradually lose capacity over their lifetime if they're being used. in electric vehicles, a lot of research has gone into how to use them so that you prolong their life. And part of the problem is that they haven't been around long enough in real life situations to know for sure how they're going to react. And so we're working on this on the fly, but they're guaranteed. I mean, companies that make a profit are now willing to warrant them to maintain 80% of their capacity at basically the 100,000 mile mark. And so for some people, they'll have more than that capacity. They don't need more than that capacity. They'll keep running their cars. Other people might say, oh, I got to sell the car. It's not doing what it needs to do anymore. And maybe they'll junk it. But at that point, a lithium ion battery pack is still pretty useful. May not be useful for the person who wants to commute, 200 miles a day, but in a stationary application, put two of these together, you're still storing a lot of energy. And if you're not doing it under the temperature conditions, the varying temperature conditions of an automobile, you're probably going to slow down that reduction in capacity. So there's a lot of post EV uses for these cells. The pack can be broken into cells. The cells can be configured in a different way. Lots of possibilities. And I think this is a realistic reuse for the lithium cells. So they're not even candidates for recycling as such for another 10 years, okay? Companies will sell you these for use in your home, especially if you have a photovoltaic array, but even if you don't, just for storing energy in off-peak hours, buying it cheaper from the utility, and using it when the utility wants to charge you more. So here's a Tesla Powerwall that you could buy now, and a Generac battery set that you could buy now. They're already on the market. They're a little expensive, but probably will be reduced when electric vehicles start to die. Okay, they haven't really started to die yet. So we have to wait and see how that's going to go. And similarly, before we can figure out how best to recycle the materials, if we want to reuse the lithium, it's going to take some time. We're going to have a bunch of these batteries to work with before companies are going to commit to a specific production line for how to recover these metals, if it's actually worthwhile. As a naive physicist who doesn't know the details of oxidation reduction reactions, I just kind of think, and what I've read, I mean, you can read a lot of different predictions for this because there's a lot of uncertainty in this, but I think that it's likely that some of these metals will be recycled from these batteries if and when they become not useful for energy storage. Okay, taking a breath because I'm now getting to the last part, and it's a big shift. We're shifting to all the reasons that I think it's going to be it can be a relatively easy transition because they're already affordable. The vehicles are already pretty affordable. They're a little bit more expensive than the same gasoline vehicle to buy, but I'll talk about lifetime costs. But they're already not luxury items anymore. They can do the same thing that your car can do, almost everything your car can do, just not quite as good for long, fast road trips. And we can talk about that. But 95% of what you use a car for, the electric vehicle will do just as well. And so range on the battery charge is good. Here's a comparison of the cost for fueling the car, whether it's an internal combustion engine. If it's an internal combustion engine, you're looking at the blue curve for a historic view of gasoline prices corrected for inflation in the United States since 1995. Anybody who drives and buys gasoline, and you're using the left-hand scale. Anybody who drives and buys gasoline knows that the price of gas changes quickly, goes up and down. You never know what it's going to be 1 week to the next. The other curve is the historic price of a kilowatt hour of electricity. Well, yeah, it's on the right scale, it's the price of a kilowatt hour of electricity at residential rates. Doesn't change as much. It goes up and down with the seasons, but on the whole, not nearly as volatile. Now I put 13 cents at about the same place as $1 on this scale, because that gives you the equivalent amount of energy at the normal residential rates in the United States these days, so that it's cheaper to use electricity to power your car than to use gasoline, at least right now at average rates, and when gas is like $2.50 a gallon. Okay, if you want to make this calculation, no matter what the price is, all you have to know is that 8 kilowatt hours of electricity will do the same job as a gallon of gasoline. Very close. It's an approximation, but it's very close. Takes into account efficiency, weather, size of the car. You don't have to worry about any of that. If no matter what size it is, if you're comparing two similar cars, this will do the same job. And so if you know what you pay for electricity, it could vary and it could go up in the future. But if you know what you pay for electricity, you know what you pay for gasoline, you know that it's going to be cheaper in most cases to run the electric car. How much cheaper? Well, let's compare that with the initial additional cost of buying the EV. Okay, the EV costs more to begin with. So that's the red dot over here on the left. And the same kind of internal combustion engine car you could buy cheaper for the blue dot. And this is based on a real example for right now. Note the suppressed zero. So it's not half the amount, it's a few $1,000s more expensive to buy the same car in EV instead of gasoline. And if gasoline price and electricity price stayed the same, you'd pay this much. Your accumulated cost to run the electric car would be like that for 11, 12 years. But at the higher price of gasoline, even a constant price, your cumulative cost would rise faster and eventually it'd be the same. And then if you kept the car longer than that, the electric vehicle is cheaper long-term. If gasoline is not $2.50 a gallon, but $3.20 a gallon, obviously that crossing comes earlier. If electricity goes up, crossing comes later. But in most cases, that's going to cross over. And if you keep the car for more than 5 years, your total cost is cheaper for the electric vehicle right now, and the costs are getting lower. And that's just compounded by the maintenance issues. Okay, very little maintenance in the electric car. It's much simpler than the contraption that is at the heart of your gasoline car. So that means you don't need oil, you don't need air filters, oil filters, all kinds of stuff that you routinely have to do to keep your gasoline car running. You don't have to do for the electric vehicle. It's really nice. Driving, it's really nice. I know there are a few EV drivers in the audience that can back me up on this. They're just really smooth, really quiet. They're not shaking you all the time. They shut down. They're just not running at stoplights and stop signs. It's just great. And they're recovering the energy that you had to use to get it going. They're recovering that and putting it back into the battery instead of rubbing it off into heat and wearing out your brakes. So your brakes last longer. It's just great. You don't have to put the gasoline in, smell the fumes. Doesn't matter if you forgot to turn it off in the garage. Doesn't matter. And that's not all. There's more. electricity, we don't have to provide a whole new distribution system for electricity because we already have that. Electricity is everywhere, at least where people live. You don't have to go to take it to the shop as much as you have to take the other car. I'm not even done. You can use the oil for something else instead of burning it up. Safer. Everybody wants self-driving cars. It's a lot easier to have a self-driving electric car than a gasoline car. I've already done this last thing. I've used the energy in my electric car to run my refrigerator when the power went out. Okay, it's not all rosy. You can't buy an electric car as easily as you can buy a gasoline car. Part of that's inertia. We could appreciate in Michigan how the automakers have invested so much in gasoline, in making gasoline cars. They are slow to change. It's hard to educate the consumers because there are things that are different that you'll have to get used to if we actually want to do this. Range anxiety is a thing. There aren't as many charging stations out there as there are filling stations. You have to educate people that you have a filling station in your garage if you have a garage. You'll notice if you're already worried about range, you'll notice that it's much shorter in the winter. Even though it's also true with the gasoline car, you don't even notice it as much. People worry naturally, and they're right to worry about this slow degradation of the storage capacity of your battery because it's a big component. It's not easy or cheap to replace it, but we have to understand that it's slow and long-term. But these things are all being improved as we speak, and a lot of it is already quite manageable. And I need to end there because it's almost end of our time. So I want to thank you with that. I want to go to my concluding slide and say that EVs are worth a serious look for anybody that's interested in the environment and sustainability over the long term. Thank you for your attention.
Thank
Should I
you,
keep-
Paul.
Okay. Yeah,
Should I keep sharing or should I look at everybody?
I think stop sharing so we can see each other.
Okay, I'll do that.
Yeah, thanks, Paul. There are a couple questions that came in the chat room that I don't feel qualified to answer.
Hit me.
But then I'll ask those, and then people can ask other questions as well. I don't think that the question about mining pollution satisfied everyone on this call. In particular, some of the practices used, especially the lithium market, seems to be quite volatile. I don't know if you have any more insight than what you provided.
I don't have much. I think there's a lot you can read available on the internet, and you can try to decide for yourself. But just keep in mind, the quantities. That's the only thing I would put in. Yeah, I mean that's about it. Maybe Steve, you've been reading overnight, I see. Do you have any comments about that?
No, not really.
The only thing I would contribute is to think about the quantities, and that it's not consumed by the car. Okay, so the ramp up, if we want to ramp up, it means ramping up lithium production for a while, but you can certainly imagine a cyclic lithium economy that is stable, that doesn't require lots more to be added, every year, with recovery from old batteries. But it's far into the future. I think that mining has to be dealt with, and it has to be done responsibly, but that it can be, it should be, it can be, and as far as the economics of it, that's way beyond what I'm qualified to comment on.
What about mining lithium from seawater? What do you got for us there?
It can be done.
Yeah, in terms of feasibility, I guess. I
Yeah.
guess that's another economics question.
It's another economic question. Yeah, haven't looked into it in detail.
Paul wants to know if there are other sources of cobalt that you know of other than Central Africa.
Yes, there are, and it's just the economic question. There's a good place that happens to be a place where there's cheap labor, and so that's where people buy it from. If you can get some regulations in place, it'll become lucrative to develop other sources. It's not geographically, it's not limited to that one deposit.
Are there other questions that people have? You can, I guess you can just pipe up or raise your hand.
Yeah, I can stick around. I don't know what everybody else's schedule is.
Kate
Jeff?
Miller, I see your hand. You're muted though. There you go.
Now am I unmuted?
Yeah.
Okay, thank you. I have an electric car, and we've been told only charge it as much as the distance that you're going to go. Don't keep it full. And then now I've been told, in the wintertime, it's good just to plug it in every night anyway, which fills it up unless I put a limit on it. And I'd love some more opinion on that.
What kind of car, Kate?
It's a Tesla.
Okay. Yeah, in general, we believe, okay, I'll say again that the technology is fairly new and we're still learning, but the prevailing opinion is that time spent at 100% for a lithium ion pack accelerates the slow degradation.
Okay.
So if you're about to leave for a trip, set it up, use your timing so that it reaches 100% when you're about to leave, and you're great. Leaving it 100% for days, especially in hot weather, you should avoid.
Thank you very much.
Jeff, I think you were in first, and then Pete.
Paul, I think like me, you see a lot of electric bicycles coming, now skateboards, one wheels, and other devices. How do you feel about single user devices like that in terms of electric vehicles and the market?
I personally like them a lot. The amount of energy it takes to move me from my house to my workplace is a lot less if I'm not carrying 1,000 pounds of battery with me. I can do the same job. If it's moving me that's important, I can do the same job a lot better with a smaller vehicle. So I'm all for smaller vehicles.
Paul, great job as usual. Wouldn't expect anything less from you.
Thanks, Pete.
But my question is on the level of charging station, level 1, 2, 3, or beyond. Where are the trends going for level of charging station? And where do you think best value is, whether it's the university buying more charging stations? Well, let me ask this. What's Paul's next charging station? What level are you going to be buying?
I have level 2 at home, and most EV drivers that have attached garages or don't live in multifamily buildings will find it useful to have level 2 in their garage. And so we'll have less need for charging outside the home because they'll be able to charge every day, every night, and they won't need to do much charging on the road. Their need will be on road trips when they want even faster charging than that. And so there'll be, even for them, there will be a need for what you call level 3, which really isn't called level 3, DC fast charging, the big expensive machines that should be located on interstate highway routes around the country, rest stops, destinations, museum or places that you're only going to visit for an hour or something on the road. They should be equipped with these big expensive things. Universities shouldn't worry about a level 3 or a DC fast charger, but for the large number of people who won't necessarily be able to charge level 2 at home, workplace charging, other destinations where a car sits for several hours, but I mean, especially that's places people work, but could also be movie theaters or things you can imagine where cars sit motionless for several hours. They should have level 2. The more they have level 2 available, the more it'll be easier to spread this adoption wider and wider, and it'll be seen as routine, and the easier that's available, the less people will be inhibited from buying them in the first place, because they know that there's going to be charging available when and where they need it. So that's why it's important for universities and other employers to install level 2 chargers and keep them working, in my opinion.
I think you're going to get some more questions, but given time, I would love for everyone that's still here to please give a huge round of applause to Steve Burtman and Dr. Paul Pancella. Wow, I'm so glad that we recorded that, because I always learn something from your presentations, and I am missing doing this in person because Paul usually actually brings in the actual battery from his car and does a nice
A small piece of it.
Right, about how you couldn't do that with the internal combustion engine. So I just want to pause and say thank you so much to both Steve and Paul for putting this together and educating all of us today. And Paul, if you're willing, Steve, if you're willing, and some folks want to hang out maybe for just a few more questions, if you're willing to do that, I'm happy to stay on, but I'll stop recording so we can speak freely as well, and close this formal session for those that do need to leave.